Hi, my name is Peter, and I'm one of the co-founders of Chang and Elevado Industries. And here today, I'm going to present to you the PK processor. And for the agenda today, I'm going to talk about the company background, the design guidelines, baseline instruction set architecture, the register set, data types, addressing modes, instruction formats, instruction set, and feature improvements, and then we'll have a question and answer session. So Chang and Elevado Industries is specialized in designing processors, and the company was founded in September of 2014, and it's located in Long Beach, California. The idea for the company came from our CECS 440 computer architecture class from Professor Allison. And PK stands for primary key because the CPU is generally the brain. So then, which is usually the primary key to any computer as it unlocks its full potential. And for the design guidelines, it was based off of our book from Hennessy and Patterson, Computer Organization and Design. And then also from the phrase, simplicity favors regularity. And that's where we have the 32-bit instruction set and also limited instruction types. Smaller is faster, so then we incorporate 32 64-bit integer registers and then 32 64-bit floating point registers as well. And then a good design makes good compromise, and that's where we have the Harvard architecture versus the von Neumann architecture. And the Harvard architecture is where it has two buses, one for data transfer and then one for instruction fetching. And the von Neumann, why the Harvard is better than von Neumann, because the von Neumann only has one bus for both instruction fetches and then data transfers. So then the Harvard architecture will do both at the same time, and then the von Neumann will have to separate it into two. So the baseline instruction set architecture. Here's the top module, which has the CPU, then the I/O, data, and instruction. And then here's the CPU, which has this control unit and then the execution unit. Pretty much all of the control words go into the execution unit, with the ones that go from the execution unit to the control unit is the flags. And then here's the execution unit, which has the bus interface unit and then the floating point data path and the integer data path. And then here's a zoom in of the integer data path, which has like the register file, a couple muxes, and then the ALU. And floating point data path, which is very similar to the integer data path. And then here's the bus interface unit, which has like the floating point buff registers, the rebuff, the memory address register, stack pointer, write buff, instruction pointer, and instruction registers. The addition would be the extra muxes and then an extra sign extension for the split sign extension. One is for the arithmetic operations, which is from IR 15.8. And then the other one is IR 23.0 for the jumps. And the register set, so there's 64-bit general purpose registers, like I said earlier, 32 integer registers and 32 floating point registers. There's also a 32-bit instruction pointer and 32-bit stack pointer. The 5-bit integer flags, there's a negative flag, which is set when the most significant bit of the sign value is 1, and then the carry flag, which is set when the results of the in-bit arithmetic operation results in a carry. The overflow flag, which is set when the results can fit in like 32-bit space, and the interrupt flag, which is set in the event of an external interrupt. And then there's also a zero flag. There's also the floating point flags, which is greater than, equal to, less than, equal to, equal, and then not equal. For the data types, there are 64-bit signed integer registers. It has 8 bytes, and then for the 64-bit floating point registers, there's the fraction, and then the exponent, and then the sign bit right here. And then for the addressing modes, there's immediate addressing, which the 8-bit constant or immediate field from the instruction register, it performs an operation with the register's contents. And then there's the opcode, the source one, and then also the 8-bit immediate, and then destination register. There's also register direct and then register indirect, which have the same setup with the opcode and then the source one register, source two, and also the destination register. Then for instruction formats, there's the triple operand instructions, double, and then single. They all have very similar format with the 8-bit opcode, and then for the triple operand instruction, it uses both the source 1 and source 2 register, and then it stores it into the destination register. And then for the double operand, it has the source 1 register, and then the destination register, and source 2 is just left alone. And then for the single operand, it just utilizes the source 1.
Doesn't it use the destination on single? Like I could decrement R1 and put it in R7?
Oh, yeah.
Yeah.
Sorry. Here's the instruction format for conditional jumps and unconditional. There's the 24-bit sign extension, and then also and then for the flags, there's just 0, and then just utilize the opcode. And then for the immediate instructions, has the opcode, source, register, the immediate, and destination, like I said. For future enhancements, I wanted to implement the barrel shifter, which shifts a specific amount in one clock cycle rather than shifting multiple clock cycles. And I wanted to add the barrel shifter module after the output of XMUX and the integer data path. And then also utilize a shift amount, which will determine how many times it'll shift. And then also the barrel select, which will determine what type of shift or rotate you do. Here is the integer data path with the barrel shifter module added in, and then the shift amount and the barrel select. And then inside the barrel shifter module, it'll have the different types, which would be like the shift, logical shift left, shift right, the arithmetic shift left, shift right, and also rotate left and rotate right. And then the barrel shifter will have opcode, then the shift amount, and then the two source registers. The barrel select can determine what kind of shift, and then the destination register. Any questions on this?
Just real quick on your barrel shifter, would you want to set flags or would you not want to set flags?
I haven't really thought about that, to be honest. Incorporate that in the future.
Going back to your BIU, how do you save the flags when you get an intro?
So it's going to go from the root buf, and then it's going to go from read both out.
So one of those paths at the, you've got muxes at the bottom of rebuff, one of those paths come from the flags?
Yes.
Okay. That would answer your question, right?
Anything else?
Very good, Peter. Thank you very much.